Alright, so today we're going to do the investigation of functions. So we're going to look at three different functions, that being the cosine function, sine function, and tangent function. I'm going to be giving you out some key characteristics, and that's pretty much it, yeah. So let me just move this text box and then we can start. So let's start. We're going to start with the cosine function, even though many people say I should start with the sine function, but that's okay. So let's look at the graph above. That is a cosine function. We notice that it's a periodic graph. We notice it's a periodic function. It repeats itself over and over again. So we have some questions to guide us on this investigation from the textbook. Let's go ahead and check that out. What is the amplitudes of y equals cos x? Well, you can see here the maximum is 1. The lowest is negative 1. So that means our amplitude equals to 1. Right? And now it's asking make okay, what else? So they're asking if this graph is periodic. So yes, this graph is periodic. The period is, we're going to see the period. So in our case, the period is, I believe, okay, so you can't tell exactly the period of this graph simply because it's on decimals. But usually, the period is 360 degrees, otherwise known as 2 pi radians. Now let's check something else. So we can verify this is a function by using the vertical line test, and then let's talk about the domain. So the domain is obviously x, such x is all real numbers. The range is 1, negative 1, smaller or equal to y, smaller or equal to 1. Y is all real numbers. And now, that is pretty much all the things that we have to say about the cosine function. And then notice it starts at 1, crosses the x-axis at 90 degrees and to 70 degrees. It reaches the lowest point at 180 degrees. This loops over and over again. So that is some trait that I want to add in there myself, so it's not part of the textbook. Alright, now let's go ahead and do the sine function. So you look at these functions, you're like, hey, wait a minute, they're so similar. What's the difference? Well, the sine function is actually just the cosine function, but you moved it 90 degrees to the right, 90 degrees to the left. So if you move this graph, if you move the sine graph 90 degrees to the left, it's going to become the exact cosine function. So the amplitude of this is also equal to 1. The graph is periodic. The function is periodic. And the period is 360 degrees or 2 pi radians. Right? It's the same thing as, cosine. So nothing much. Let's talk about the domain. The domain and range is all the same. So let's go ahead and copy the domain and range from here. And then now I have something to write for this. Cosine and sine function are the exact same, except for the fact that sine function is cosine shifted 90 degrees to the right or left. So you realize no matter if you shift it left or right, it's still the same thing. It's still going to become cosine. And then that is pretty much it. So there's a reason why when we looked at the table of values of cosine and sine of different angles, it looked different, right? It showed a little bit of resemblance. So it was because these functions are very much similar. So we can actually use these functions to tell what value our angle is going to be. For example, if I wanted to find sine 90, so keep in mind this is 360, so this middle is 180. So this is 90 degrees. And look at it, it's 1. So sine 90 equals 1, sine 180 equals 0, sine 270 equals negative 1, and sine 360 equals 0, and then sine 45, that's 1 half, and sine, what is this, sine 135, that's also half. So it corresponds, it kind of matches with what we learned. So yeah, we're about right. However, now let's get to the very different style, tangent. So we look at that for a minute, and we're like, hey, wait a minute, this looks so ugly. Why is this so ugly? So let's go ahead and do something to this. So we realize that when we have something, when we have these lines, there seems to be this missing spot, this missing place in here, and that's kind of resembles something we learned when we had the function 1 over x, right? We have asymptotes. So these are lines that the function will try to approach but can never intersect. So these are the lines that the function will always try to approach as close as possible, however it will never intersect the line. So now I want to talk about something. Yes, this is also a periodic function. However, it doesn't have an amplitude. It does not. It doesn't have an amplitude as its y values will go as low as negative infinity and go as high as infinity. So technically, if we continue to draw, this is gonna exceed the screen. It's gonna go all the way up, and it's gonna go so up that we can't even see it anymore, right? So no maximum or minimum value. Okay. And now, this one is the only one that has a weird domain. X can be, so X, let's see what X cannot be. So in this asymptote right here, this asymptote is actually, if you can't tell already, it's actually 90 degrees. So on this asymptote, because it's an asymptote, so we're actually not defined there. So we don't have any values there. So at 90 degrees, if you put that in your calculator, tangent 90 is going to give you an undefined answer. So let's go ahead and try that actually. Sine 9 tangent of 90 degrees. That's going to give you math error, right? It doesn't define. So that is where the asymptote occurs. And then we realize it occurs at 90. And then what value does it occur again? Tangent at 270, right? If we look at the value of 270 on our calculator, we're looking, hey, wait a minute. Whoa, it's undefined again. So domain x does not equal to 90 plus 180n, right? So it will repeat itself every 180 degrees, and you will see why soon. N such that n is a list of whole numbers. So we can't have n as decimals. We can't have 0.5, 0.3, or anything. They have to be whole numbers. They could be negative numbers, but they have to be whole numbers. And our range is y such that y is a real number. All real numbers. And remember, we have to write that for x as well. Otherwise, it will be discontinuous. X is all real numbers. Now, finally, the interesting part is its period. The period, instead of 360 degrees, well, notice this is negative 90 and this is positive 90. Period of this function is 180 degrees. So out of every other ones, tangent is the only special one that has a shortened period, has an infinity amplitude, and it has a special domain and a special range. And that with that, we have introduced our functions. So you should learn how to draw these. So cosine starts at 1, goes down to -1, goes to 1 back up. This occurs at 90. Sorry, I'm actually go ahead. I'm gonna go sketch it for you. So usually we will separate these into 4. Oh, that's not what I meant to do. Into 4 sections. 90, 180, 270, 360. And this is our axis. So for sine, you would start at the axis and you would go up here. And you would go up. You reach the highest point at 90 degrees. You go back down. And then at 180 degrees, you cross your x. So you go up here, cross your x, go down, and then go back up. This is one cycle. And then make sure you smooth your corners. Right? I drew it pretty bad, but you should do better. So for cosine, I want you to point a dot over here. This is your lowest. And so let's go ahead and do that. So we cross our x-axis at 90. And then we go to our lowest point. And then we get back up. Right? So this looks kind of bad because I kind of scaled this out pretty bad. And now we have tangent. So tangent has this this asymptote over here. So it's gonna look like this, and then this part is gonna look like this, and then it approaches, and then for here we have it again. Right? We have this. That is our tangent graph. So I've drawn every single graph for you, and you should learn how to draw them. Next class, we're going to deal with transformations. We're going to see how these graphs get enlarged, or they get a horizontal horizontal stretch, a compression, and a vertical stretch and compression. Okay, if you have any questions, feel free to reach out to me, and I will